So for this question, this is question 7. We are supposed to prove that cos 3y minus cos y over sin 3y minus sin y is equals to negative of tangent 2y. So looking at how the endpoint is 2y, likelihood is I'll start with the more complicated side, and I'll try to change everything to sine and cosine with the endpoint in mind. Just like all the tips that I used to stay with you during lesson time. Okay, so the first one that strikes my interest would probably be the 3y. Since this 3y does show quite a lot of potential to be, split up into 2y, right? So, which is what I'm going to do. Using the compound angle formula or the addition formula, we know that cos A plus B, that is in your formula list, right? This is the same as cos A cos B, subtract sin A sin B. So that's what I'm going to do here. And similarly for sin 3y, we can use the fact for addition formula for sine, which is sin A plus B is the same as sin A cos B plus cos A sin B. Okay. So with that, cosine 3y, I'm going to split it into cosine 2y plus y. Okay. So if I see this as cosine 2y plus y, then I can rewrite this as cos A cos B minus sin A sin B minus cosine y over sin A cos B plus cos A sin B minus sin y. This is just me starting with the left hand side. So what do I see next is now I observe that like before I try to break it down even further, I mean I'm quite keen on keeping the 2y because I saw a 2y here. I observed that there seems to be a common factor here, cosine y and y. Similarly for the right hand side, I do see like there's a sin y and sin y that I can keep as a common factor. So I'm interested in looking at the first term and the third term, factorizing them together. I have cos 2y of cosine y minus 1, keeping my first and third term together, minus sin 2y sin y. Okay. Similarly for the denominator, I do the same. This is sin 2y cos y plus cos 2y. Sorry, should be sin 2y. I made a mistake. Quick check. This is cosine y. This is 2y. This is sin y and cos 2y minus 1. So why am I so interested in having a cos 2y minus 1? Because if you remember the double angle formula, that cos 2y is the same as 1 minus 2 sine square. Okay. Then I can also say that cosine 2y minus 1 is the same as negative 2 sine square. Now remember, this is the double angle formula for cosine 2x. Alright, so that's what I'm going to do to these two terms over here. I'm going to write this as negative 2 sine square y. Similarly, this is negative 2 sine square y. Okay, so let me rewrite it. This is cosine negative 2 cos y sine square y minus sine y sine 2y. Denominator will be sine 2y cos y minus 2 sine cube y. Okay. Now with that again, what do I go about doing next is I now see that probably this sine 2y can be converted. So I'm going to convert my sine 2y using double angle for sine as 2 sine y cos y. And this also as probably 2 sine y cos y. I now end up with my numerator to be negative 2 cosine y sine square y minus 2 sine y cos y over 2 sine y cos y minus 2 sine cube y. So again, because I'm looking at my denominator, I'm looking for things to cancel off. So what I see here is, oh, both seems to have a 2, a sine, a cosine for me to retrieve. So the numerator, I'm going to happily take out negative 2 sine y cos y, leaving cosine y in, sine y in the center, and minus 1. Okay, which is what I'm doing now. And my denominator, I'm going to retrieve 2 sine as well. So I take out 2 sine y. This is cosine y minus probably sine square y. Do I get something like that? Oh, sorry, this is cosine square. So this is cosine square minus sine square. Okay. Sorry, I missed out a square here. Let me just put sine square y minus 1. And this would be my cosine 2y. This will be my sine 2y. Okay. And sine square y minus 1